So we'll take a look how I can take a look at how I implemented the classes inside the Monkey language. Monkey language is from this book, Writer Interpreter in Go. I found out his book was Primagen. You should be knows a famous YouTuber. And after you read the whole book, there's basically going to be a full-blown interpreter. It isn't very complex, but you can do a lot of stuff. There's a REPL and there's a lot of test cases, and you can play around with it. So to have a little bit more fun in this experience, I tried to add class support, because I think that if you can, every time that you read something, you will understand it, but every time that you actually put your hands on it, you will get perhaps you'll get a better understanding. So this is the project files. You can take a look at them in my GitHub. I'm just going to highlight my best parts because you can always download the folder of the original creator. So there's no point in seeing about that. Rather, we should take a look about how I did the classes. So the first step should be to fix the tokenizer. Basically, I added the new keywords needed. So it would be colon, class, new, dot, and private. Out of this, I should say tokens. Out of these tokens, new and private class are new, private, and class are all new keywords. Then we go to the lexer, and in the lexer is where we actually translate from strings to tokens. Mainly here you would go and add your cases, which is very simple because we're gonna add a colon token every time that we find a colon. Same for the dot. And I want to say the same thing for the class, but don't see classes. So this goes only for the new token. To test that this works correctly, you just have to go to the lexer and add some test cases. This time we only see that every single syntax that goes in is correct, so that the word class has meaning, hello has meaning, and so every symbol that goes in should translate to something, as you see here. So class is a keyword, and Bambi is an identifier, which is a type class, colon is a colon, and so forth. This was the step where you actually just take and this is the step where you only translate the syntax and have no checks. It would be valid to go class because the compiler wouldn't know any better. The lexer doesn't know any better. She just tells you all of these tokens exist and they are valid. Next step is going to the parser, and inside the parser we added the dot operator. Since it's a postfix operator, you would have to interpret this every time there's some expression like this. So a dot is the postfix expression. You put in this hash map of token types and the correspective enum to give the order in which operation should be resolved, and you register this function to be parsed. This is for the dot. The most interesting part, I say, is the parsing of a class. So the parsing starts here. Originally there's only the program statement, but I added the class statement. This was because there's no really state. When you type program.statements, append statements, you're gonna parse the statement. You don't pass any state around, and classes need to be defined, then initialized. Therefore, it's not really possible without rewriting big blocks of a program to just reuse the same codes. So I got a little bit creative, which you could say I got a little bit lazy. And rather than do that, I just said, hey, I'm gonna make a classes, which is another program, and then we keep the reference to every class. So if I find a statement that's not nil, well, that's a program. If I find a statement that matches to a class, well, that's a class. Afterwards, I can then recopy everything inside. But before that, let's take a look at how the parsing statement actually works. We would go to parse class statement. So every time you call a parse statement, you would switch between the three types of statements, which is let, return, and parse, and class. So take a look to the class expression. I'm going to read one token and create a new statement. If the next token is not an identifier, we can go out because it should be class A or something like that. Anything after a class cannot not be an identifier. Now we could also have a colon. So that would be inheritance in the monkey language. Therefore, we can have a branching in which this is inheritance. So we need to check if there's a token colon. We're gonna skip the identifier. So we're skipping A, then we're skipping the token, and we register the father. It's gonna be useful later. Now afterwards, again, class A has to be a left brace. We cannot go ahead if it's not a letter brace. And finally, you're gonna loop through everything that there's inside the class and parse those statements. Then you return your class. As for this is for the defining portion of the class. As for the initiation of class, which would look something like let A equals new A. This will define new object A of class A. I reused the let statement, which is in this language is needed to init a variable or a function. Therefore, we're gonna have to add some code to the parse statements, a little bit aside for the private, which looks something like this. Let A private equals 5. So we can equals 4, so we can protect private attributes. Then we're gonna take a look and see that if we have a new after our equals, then we should save the class name and the name. A defined class doesn't have a name, while a initialized object has a name. So we can go back to the top and take a look at my monstrosity, which basically it's a lot of code, an ugly code, but the main takeaway is that I'm gonna try and look in the classes. If any class doesn't have a name, well, that's a defined class. If someone has a name, we should copy everything that we defined inside this class, like so. We are appending it. If also there's a father, we have to append that as well. Then we'll take a look at every case where there's a father, and we should either copy the remaining tokens, or if they have the same name, we obviously don't copy that because the last valuable attribute should always be the one of the son. So if we have two A's, there should be the second A, the A inside the son. And that's it for the parser. Once we parse, we need to go to the evaluator. So this is where the code actually gets used. So far we tokenized it, we made sure that it made sense semantically, and now we're going to execute it. Before executing it, I'm gonna take a look to the object class. The object class, since this is a functional and dynamic language, everything is an object. So we have to add our class object class. Like so. This is a bit of boilerplate, but the most important fact is that our class is a type class with a body made of statements and one environment, which would be the scope of your class. So going back to the evaluator, there's a long list of the evaluations which calls itself starting from the program, and you're gonna keep evaluating until you ascend the evaluation tree. Pertinent to us will be the class statement, which I forgot beforehand to talk about. But basically, a class statement, we're gonna have a token, a father, a class name, a name if it's an object, and a block, which is a bunch of statements. While the class expression is when you're gonna call a class. So suppose we have our object A and we want to call the attribute A, that's when it's going to be parsed as a class expression. Therefore, if we find a class statement, that means that we have to create a new enclosed environment because we're gonna have some new environment to work with. The definition, the environment is really nothing weird. You're gonna have a store, so we're gonna have a hash map that stores our objects. An outer environment, like when you're in a class, when you're in a function, there's going to be an inner environment. And the class, since class is gonna get used outside of our functions. Unlike functions, you can just define and use them. You have to define, init, and use them. So again, I got a little bit creative. The language was not intended to have all of these features, so I just fought for myself a little bit. I appended a little bit. So right here, we're just gonna have to range over our block and set everything as a string. So we will give out the name of whatever is inside, and we eval it. And you see, this is the name of the function we're in, which basically means that we're gonna make some recursion to make sure to give out the values that we want. By this time, you're gonna have the environment that have the class statements, so we can go and actually work with our expressions. This case is honestly very similar to the previous ones, so nothing really that hard. So if we have a variable, we should check if this variable is not private, then we can return it without a problem. Otherwise, you have to do it inside a function. And again, if it's not a function, you don't have to return anything. We are going to return nil. But if it's a function, we're going to evaluate this function, give them the enclosed variables. I haven't touched anything about the REPLs, but very similar. When you type Python, this will allow you to test the program. You can test this language at monkey.dev. I prepared some snippets for you to type, but you can always just add or do whatever you see inside this basic syntax. And I'm gonna say, very satisfying project. I would encourage anyone to give it a try. It's not that big of a book. It's 200 pages. You could probably go in it in about 20 hours. Shouldn't be that long. And have a nice one.